Well, welcome back from the breakout rooms. I see there's a lot of activity in all these classrooms and a lot of cameras are on. I'm sure that people want to share. But first, I want to say a big thank you to Annie and Bryce for leading our college mentors who were leading in the breakout rooms during the design process. But I don't want to take away any time because I know that there's some people who are ready to launch right now. We have our Q&A wrap-up who is going to be led by Betsy, and we have two amazing college mentors, Lonnie and Owen, who are going to introduce themselves. So you guys can take it away.
Awesome. All right. Well, I think we have some students that are ready right now to go ahead and get us started. Um, Jillian, who should I pan to first? Should it be
Ah,
our
Jersey,
takeovers?
maybe Union City,
Union City?
Leicester, Thomas County, our schools with our engineers. I mean, they're ready.
All right, let's go. Let's get hands raised and we'll go straight to your students here. We cannot wait to see you all.
If there's a group that is ready, let me know. Raise your Zoom hand or type in chat and I will spotlight you. We do have two ET staff engineers live at schools with an ET takeover. I don't know if their groups are ready. Oh, let's see. I don't see any hands raised. I see a lot of people at cameras, but I don't see who's ready to unmute and go.
All
All
right.
Hallows, are you ready? Oh, Thomas County. Here we go.
All right,
They
Thomas
got
County,
their
let's
hand.
do it.
Can you unmute?
Yeah.
And Betsy, if you could stop sharing. There we go.
All right, we have a team ready to show off here, so we'll adjust our camera to them as they move into position.
Sounds
And they're not loaded on the string, so if we want to wait a moment, let them get set up, I'll come back to you.
sure. As all of the schools get loaded onto the strings and getting your launch rockets ready, we can introduce ourselves a little bit. And then when you raise your hands, we'll just pan over right to you if that works with everybody. All right. So, Lonnie, would you like to introduce yourself?
Yeah, so nice to meet everyone. My name's Lonnie. I am a senior at the University of Notre Dame, and my future is going to be in tech consulting for the cloud, which is pretty exciting. And my major is computer science. I help out with ET as a mentor and an intern. To go into a little bit of my engineering timeline, during high school, I did do PLTW, so I don't know whose schools have that, but it's an engineering program for high schoolers. It's pretty great. And so I had that for 4 years all throughout high school. And so coming in freshman year, I did want to be engineering, but then I switched over to computer science, which is still in the engineering school. I haven't given it up. But then I joined SWE, which is Society of Women Engineers. And I finally took my tech consulting internship as a junior, and that's how I've worked my way up to as a senior, graduating with my computer science degree and moving on.
So cool.
And then I just thought I'd spot like this. I don't know who knows of Blue Origin, but I actually got to visit it. I'm up in that photo in the corner there just a couple weeks ago. So that was really, really cool to see. And that's exactly what I was looking at right there. So it's a little different from the balloon rockets, but it was a lot of machinery. Couldn't understand everything that was going on, but it was really cool to see.
I love this so much. Way to go, Lonnie. Thank you so much for being here with us. All right. Do we have any hands raised, Monica?
We have a team ready and they're on the camera for Thomas County Central.
All right,
let's do it. All right, here we go. Oh, exciting. Awesome. I saw that go up. It got about halfway up. Is that right? Give me a thumbs up.
That's right. They got about halfway up. What happened, girls? Did everything go off as planned? Not really.
Really, tell us about your design. We would love to hear it. Like, how did you design it? How many fuel tanks did you have?
Oh,
Hi.
Okay, that makes more sense. So like we took one big balloon at first, just as like our main body. And then we took one of our pieces of paper and we first like took a ruler, we put it like against our balloon to see, you know, how tall it was, or I guess basically just like the width from like bottom to middle to see how big we needed to make our fins. And then we took our like one of our pieces of paper, traced the ruler or traced the pencil across the ruler, and then cut it out, and then we used that fin as a template for our other three. And we put those like towards the bottom. And we took 2 extra balloons as like a thrust somewhat and put those like on each side to like help push it upwards. Um along with the main body propulsion. But
I'm loving that. You know what I heard?
Yeah.
I heard you measured things. I heard you drew them out. I heard you designed it on paper. And not only that, but you were trying to make sure all your fins were identically cut and making sure that it was symmetrical, right? And so that are some of the key designs for spacecraft. Now that you saw it, and it did get some good height, I saw back there, what would you change and make different?
I guess we could like make it easier to unclip all 3 at once. Because we had a bit of an issue where we like couldn't find the tape roller because we didn't know where it was in the room. So what we did is we just took a lot of our smaller rubber bands and tied them together to attach our 2 smaller balloons to our bigger one.
Gotcha. Okay, I like that. So you're like iterating in your mind, like how could I make it better? And I like that you were thinking about the timing because you know you don't want one rocket to go and then another one because we'll start having it go off to one side or another. So that was really smart thinking on your part. Way to go! High five to you and your team. It's so cool to see all the things that you guys are accomplishing.
I
Thank you
love
so much.
it. I love that you started with one big one and then you kind of added to it as you went on.
All right, it looks like there's a second one getting ready. Are you ready to launch that one, or we have to string it up through the launch tower there?
I think we have Lassiter High School is ready with that launch. I'm gonna spotlight them because I see them on the ground ready for that launch. There they are. Can you guys unmute at Lassiter?
Oh yeah, look at that. Should we count it down? 3,
We can't hear them, but we can see you. You go for that launch.
3, 2, 1, go. Oh yeah.
Oh,
There we
Okay.
go.
I
fantastic.
noticed some good thrust happening and it looked pretty equal. It wasn't like spiraling out of control. It wasn't going left or right. Lonnie, what did you notice about the payload? Anything that you want to comment on?
I thought it was great. I was also going to comment actually on how equal it was because I was thinking I've seen a lot of these tip over immediately and that one did not. So I was pretty impressed.
Very cool. All right, so
Excellent.
I noticed that you guys had your payload in your cup. I know we can't hear you, but you can give us a thumbs up to help us know what you were thinking. Did you have your paper clips and your payload inside and then you covered it? Is that how you designed it? Give us a thumbs up if that's true. Yeah, awesome. So you were thinking about how do I keep my payload secure, just like our astronauts inside the top of our rockets, right? We don't want them to be able to fall out. We need to make sure that they're secure. So that was really good thinking. Oh, and did you have any comments for that group at all?
Yeah, I really liked seeing how high up the payload was there. Because when you have that weight up high, that really helps you keep it straight. And your rocket was staying very straight, like Lonnie said. It wasn't going off to the side. It was very impressive.
I'm gonna have to hop in here. I see our ET staff member Joanna Cottle is ready at with Miss Pringle, and let me spotlight them. I'm sorry to cut. She's gonna cut the line, everybody. So give us a second here while we highlight. There. Let's see if I can get. Can you unmute, Miss Pringle? Can you unmute for us so we can hear you?
We're unmuted.
There you go. We can hear you now.
Hi, everybody. I'm with the amazing Phelps High School students, and they have done an amazing job building all kinds of rockets. And we're ready to test this one. You want to say who you are and introduce your team?
Yeah, my name is Amari, and my family are Sade and Avery. Where's Sade and Avery at?
Awesome. Hi. Oh, it's so good to see you all. And you too as well, Joanna. All right, we're ready to see this one launch.
2, 1, go.
Okay.
Well, there we go.
Oh
okay.
no.
You know what? It's okay. That was good. What I love about this at NASA, we talk about failing and we fail fast because that's how we learn, right? You guys had a sticky valve, it looks like I call it, when your valves don't open up right away, but that's okay. That's what happens in real life too. And we just redesign and try it over. So if you get that rocket blown back up, we'll come right back to you.
Team was really ambitious and tried to do a double payload. I think that might have been part of their struggle. Payload that they were trying to launch into space. So thank you.
Yeah.
Wow.
Very ambitious there,
Oh,
Phelps.
good, good.
Awesome. So
I
we
love
have
it.
our next ET takeover who is ready. Where is he? There he is. I found you, Jerry. All right, we're going to go to Archbishop Stepanak. Can you guys unmute for us? Oh my goodness, look at this, balloons. How many balloons are there?
Oh, yeah.
This is
Oh my God, I'm
amazing.
loving the enthusiasm.
Can we unmute Archbishop Stepanak? Let's see. Oh,
We don't hear you,
we
Jerry,
don't
but
hear
we
you.
can see you, and that's what matters. Let's see what
Oh,
your
there they
students have
go.
done.
Can you hear it?
We can hear you.
Okay, you can hear it. All right. Hello, everyone. If you got staff engineering here tomorrow, here at Archbishop Stepanak High School, in New York, we are ready for one. Before I go, I'd like to introduce our teacher, Mr. Keller. Brian?
I know her.
Hi.
Yeah, so in this group, we have Renzo, we have Richie, and we have Jason that are working together on their current design. Then we have 9 other people that are also here kind of doing their own things. We're all very excited to see a successful launch. So we are ready for a live launch. Guys, go for it. Let's do a countdown. 5, 4, 3, 2, 1. We got it.
Whoa!
Yes!
That was awesome.
That was amazing.
I'd love for you guys to keep your name, talk about your design, talk about what you've done. Good. Keep your name.
Renzo's the lead designer for it. We kind of figured the more when we put on it, it would give us more thrust to reach the top.
Great. Renzo, what's your name?
My name's Renzo. I'm going to design it and first sketch it out just to make sure that you can drop something inside of the and for our design, I'd say that our was actually smaller than those longer balloons. It had a lot more effort considering they work that well. We expanded a little bit.
All right.
Awesome. And I noticed.
Do you have any questions for the team?
I sure do. I noticed you had 3 really long balloons, like you mentioned. The one in the middle, was that also releasing, or was that just holding your payload?
It was holding our payload and also giving us our terminal stage or our center of the station.
Okay. Yeah, I see it there. Yeah, so
Oh,
it's still
I like
intact there.
it. It looks just like a rocket there when you're holding it like.
The payload is here, Betsy, went all the way.
Oh yeah, I am loving that. What a great design. Don't you think it looks like the rocket you just saw, Lonnie, last week?
That's exactly what I was thinking.
Super job, you guys. High five to your team.
All right, great. All right. Any questions?
Great job. Thank you, Archbishop Stepanak. We are going to All Hallows next.
All right, thank you.
All Hallows, can you unmute for us? Look
Oh,
at this design.
Oh yeah, I am seeing some good aesthetics on that one.
This is our rocket, Danny.
It's an interesting design.
2, 1. All right.
Awesome. You guys chose to go horizontal. Lonnie, what questions do you have?
Well, first of all, I love the landing too. You had it perfectly marked. I don't know if it was meant to, but it really did go straight into that area. My question is, how did you decide where to put your payload?
Wait, what she said?
Can you repeat that?
How did you decide where to put your payload?
What is that? Just read it.
Where you placed your payload, how did you decide where to place it?
Just did whatever like we thought that would look good because we trying to make like a car. We trying to make our rocket look like a car.
I like it. Super smart. And you know what? All cars are symmetric, just like space vehicles. And so that's a super good thought in order to balance out those forces. I love it. Nice work to you and your team.
Fantastic job, All Hallows. All right, we have Union City is next in line. Union City, can you unmute? We are ready for you. I know you guys have been waiting. Can we unmute Union City? I think they're working their lunch. Oh, somebody's at the computer now.
Oh, hi.
We
Sorry.
can hear you. No, you're good.
We're ready. Okay, who's here? All right. Okay, let's see. All right, can you go back to the other side so that, yeah. All right.
This is a good camera angle. I feel like I can see it all.
So true.
Yeah, whenever you're ready. Oh.
And just like any rocket launch, we have to get ready and make sure all systems are go, which is what it looks like we're doing here. Good job, Union City. I cannot wait to see this one go off. I also can't wait, Owen, what do you think, to talk about those payloads on that red balloon it looks like?
Yeah, it's super interesting. I like how the payload was being split up. It helps balance out the weight. It'll help keep it straight. I'm curious why they don't have one of the payloads on the pink balloon. It seems like the red balloon's gonna do a lot of the heavy lifting.
Yeah, go for it. Should we count down?
That's right. 2.
Yeah, here we go. 3, 2, 1.
Oh,
launch.
Oh,
We do have others set up.
All right, let's go. We'll
Oh.
take them.
All
That
right,
was a
guys,
nice job. We do want to ask the gentleman a question if they have a second. Why they designed the payload the way they did. I heard Owen asking.
Marco, why did you decide the payload on each side?
I wanted to have like one more thrust on the colors.
More thrust on one side on the cups?
Yeah.
I think
The first one that went out of there was the lower one.
so that, yeah, so I think the point was to balance out the payload on either side, so there was even weight distribution.
Right.
And that second, the pink balloon would be the extra thrust to keep it going, right? Is that what you wanted?
Gotcha.
I like the different designated roles to each of the balloons too. You thought it out.
We do have a couple others ready to go if you want to get one more.
Sure thing. Let's do one more. I see them sitting there in the hall, it looks like, or in the walkway. Hello. All right, you ready for a countdown?
All right, get them ready.
All right, Owen, you want to count it down?
All right, 5, 4, 3, 2, 1.
Oh.
I think
One of them didn't really go.
I think the string was a little weak.
I noticed that. And well, in regards to that design, if those gentlemen are willing to talk about it,
Yeah, sure. Steven.
it looked really nice and symmetrical with your 3, and it looked like you had them all nice and bound together well, which is what any rocket would need. What did you notice about your flight?
What did you notice about the flight? What was the problem, you think?
I don't know. I'm assuming it's the weight. Like we put like the how call it, the cup in the ball, like in just one balloon. We didn't put it like in the middle. So I think that's why like it shifted. You know?
The weight distribution was uneven. If you had put the balloon, if you had put the cup where?
And like in the middle.
In
like
the middle of the balloon?
Yeah, between all the balloons. I feel like that would make a difference.
It's a good idea.
Do y'all hear that? They are actively learning. It is so cool that you guys came to that conclusion all on your own just by testing one rocket. I am so psyched because you guys are learning so many things, and I can't wait to see how you're going to apply them in the future. All right.
We have Challenge Prep that is ready. I see their launch is ready. I'm going to spotlight them and ask them if they can unmute. Challenge Prep, can you unmute? Check out this launch.
Okay,
If I do it, it'll
Wow.
having a little argument about how to stretch the line. That's the lead here. We're discussing the best ways to do it. Okay, all right, gentlemen.
Alrighty. 3, 2, 1.
Oh. Okay, okay, yeah, we tried. All right.
You know what's cool about that one? I noticed that they didn't completely deflate, which means you've got a reusable rocket right there. And
Yeah.
you guys could reset up and retest, just like we do reusable rockets. Have you guys seen the SpaceX things that are now reusable, even the launch vehicles? So I cannot wait to see you guys relaunch again. If you do it here on screen with us, I'll be high-fiving you even more. If you do it later, send us a video, okay?
Awesome.
Nice work to you all.
Great job. All right. Lassiter High School, can you guys unmute? Oh, wait, I think I skipped the line. Sorry, Phoenix is next. Phoenix, where's Phoenix? Their hand is not raised. I have to, there you are. Let me spotlight you. Sorry.
Hi, Phoenix.
All right, do you want them to explain their
Yeah.
Yeah.
It'd be great.
Hello.
Oh yeah, someone getting a screenshot of that tester all the way on the top of the bleachers. All right, do we need a countdown?
Yes, please.
All right, here we go. 3, 2, 1, go. Okay, we got a launch delay. It's good. We have those at NASA all the time. Oh yeah, look at that.
Yes.
Yeah. All right, so tell us about your design. How did you decide to create your rocket the way you did?
I mean, we just put a balloon and then we put like straws and tape. So, like, it's just a simple, simple.
One question from the student that was all the way up there is they were designing and then they're like, oh wait, do we have to put the cup and the ping pong ball in there?
Okay, so you don't have to use the cup. If you saw in the video that we showed in the workbook, the intern that was preparing that had just used the paper clips and kind of spread them across the rocket itself, but you could use the cup. I tend to try not to use the cup because what does it add? What do you think it adds?
It adds weight.
Yeah, totally. It adds weight and that makes it a little harder for us. So when you use the tape, did you have any problem with attaching the tape or having it break any previous test, or was this your first test?
It was our third test.
It was your third test. Okay, so that's awesome. Sometimes I see people who test and retest, which we absolutely want you to do to get your optimum. The valves end up sticking, but yours seemed to work great. So you guys did a nice job. Oh, and do you have anything that you want to add?
Yeah, it was super fun seeing it go at that angle, having somebody up on the bleachers. It was really fun to see. It was a pretty simple design, but it was really well made. I could have seen it going wrong, but it did. It went straight forward. It did what it was meant to. It was very impressive. Good job.
Sometimes simple is best because
Yeah.
otherwise you have to really make sure that you're all going at the same time. So this way you were able to do a one-man launch and make it easier.
Super. Nice work, you guys. Thank you so much for sharing.
We have More Catholic who is ready next. I'm going to spotlight them. If you can unmute at More Catholic. Hi, everybody.
Hi. Hi.
Oh,
So we
look
have
at those.
4 rockets. So guys, you ready? Oh wait. Okay, when should we go?
Yeah.
Yeah, let's
Okay.
count it down for them. Well, honey, you want to count it down?
3, 2, 1, go.
All right, we have another one.
Awesome.
All right, let's see the next
Wow.
launch. Oh.
Oh, they have another one for us.
All right, ready, guys?
Yeah.
You can go over there.
Feel free to count them down again, Lonnie.
3, 2,
Ready?
1, go.
I'm sorry. Ready? Hurry up, you have a big feature to show.
It's all right. I noticed your payload looks like it's still intact. So that was a successful launch abort, I would call it.
I'm noticing these are a lot more filled. I wonder what difference that's.
I can't, I'm sorry.
There we go.
Ooh.
And the last
I noticed that went really far. I think they can't hear us, but that's totally good. You guys are doing amazing. So many rockets, like bam, bam, bam.
All their rockets have so many balloons.
This one is definitely a team effort here.
For sure.
3, 2, 1, go.
Aww.
It
No
looked like it
worries.
still had a lot of power to it. It was still going really fast.
Well,
And I
thank
think
you.
Thank you.
Yeah, thank you. I hope your students enjoyed it.
All right. We have Lassiter, who's been waiting very
Enthusiastic.
patiently with their launch ready to roll. So we are going to spotlight you guys. Can you unmute, Lassiter? Oh. Whenever you guys are ready to launch, we can't hear you, but you are free to launch because you guys are on camera.
It looks like the space shuttle to me with the
Yes.
solid rocket boosters and the main engine in the middle. I love it. It's even got a name. The hot dog, I think.
Yeah.
Oh.
I love the
Almost.
spin action though that we got. That was different, but it also went straight up, which was really cool.
Yeah.
That was amazing.
Nice job to your teams. All these great active learning activities is so good to see. Do we have any other hands up?
I don't see any hands up at this moment, but if I see one,
Okay.
I will.
He'll shout it out for us. And I saw that too. They said it was too much weight. And you know what? That's an incredible observation by your students there, because guess what? You know, we're doing this trade-off. How much weight can we lift? But when we try to get more rockets, we're adding more weight. And so it's kind of a trade-off of what one or one's combination will get us the best amount to space. So good thinking to all your students out there. Awesome job. All right, I'm going to switch it back so Owen can tell us a little bit about himself. Owen, if you want to go ahead and start explaining your background, I'll get your slides queued up for us.
Yes.
Cool. Can you see that, Owen? Go ahead and tell them what school you go to and all that good stuff.
Slide's not up. I don't see it.
Oh, you can tell them without it.
There it is. All right. Hello, everybody. My name is Owen. I am a freshman here at Stony Brook University, a state school here in New York, and I am a major in mechanical engineering. We can go to the next slide. Here I have a slide up about some of the stuff I did in high school. You can see I was at a couple of STEM teams and clubs. I have robotics, chemistry, math. I did something. I was on my school's media team. It's kind of specific, but it was a leadership opportunity for me, which really helped me a lot in projects and stuff, that leadership role. And then in the middle there, I have my AP course load. I took a lot of AP classes. I was trying to be very prepared for my future because I knew I wanted to do STEM. I knew I wanted to do engineering. So I have calculus, chemistry, computer science, all that good stuff. So next slide. Here I have some pictures of some of the stuff I've been doing in college. I have a lot of robotics and circuitry there to the left. In the middle is a robot I made for a school. My school had a competition, so we made a robot. And there to the right is a program I've been doing. It's called NASA La Space. So I've been learning how to write proposals and review proposals. Bunch of fun stuff, really good stuff.
Awesome. So we have been discussing all of your designs because they are so incredible. Right now, we're going to go ahead and switch over to the Q&A portion where you get to ask us anything. And I have a few questions that you all have submitted to our team that we'll go ahead and start, but feel free to drop any additional ones like Monica mentioned in the chat, and we'll try to answer those as best we can. So Lonnie, what is the most challenging project that you've worked on and what made it challenging? Gilmore High School, Georgia, thanks for submitting.
Okay, I would have to say I am doing a project right now. I think they've kind of gotten harder as college went on because they've had to become more and more complex. But I am doing research to figure out facial recognition software and comparing those all. And so it needs to segment the face and then compare it to a different face and just kind of getting all that ready. And so I'm seeing if glasses and hats make any difference. So I'd say though, the reason that it's challenging isn't really the project itself. I'd say that what makes it challenging is that I'm doing it all on my own. I used to be so wanting to do projects on my own. And then I came to college and I realized it's just so much easier working with other people. Sometimes it can be difficult getting those dynamics out and sometimes it can make it more challenging. But I've learned that it definitely does speed projects up. And I can see so much teamwork happening here. Everyone holding the balloons together, even if it's not theirs, they're getting in there. So I think everyone can agree with me when I say that teamwork makes it so much better. So I would say that it's a really exciting project for me, but I'd say it's also very challenging just because I'm trying to do it all on my own, and that can be in and of itself a challenge.
That is a great answer. So I see one more question that was submitted by Montebello High School in California. Who is your STEM giant? Oh, and do you have a STEM giant or someone that you looked up to?
Yeah, well, growing up, I wasn't really looking to a role model for STEM, but as I learned more about STEM and science and math, I gained a big appreciation for Sir Isaac Newton. Because when you look at everything, you see just how much of calculus he was involved in, physics. It feels like everything I'm learning, it starts with Newton. He did so much work and he had nothing. He was really the basis for all of these fields. It's very impressive and very inspiring learning about him.
And speaking of STEM giants, I cannot wait to hear from our STEM giant who is joining us, our keynote speaker, the Galactic Girl. So does anyone else want to share their launches or are we ready to transition, Monica?
I don't see any additional hands up at this time. So
Okay.
I think we can keep going.
Sounds perfect. All right. Well, a huge thank you to Lonnie and Owen for being here today and helping ask questions and analyze all your designs. They come with such a wealth of information. So thank you both for being here. And without further ado, I will introduce to you Camille, the Galactic Gal. She is so incredible. I feel so honored to be here and get to hear her and get to speak with her today. She's been featured in the New York Times, the Washington Post, NASA TV, and Fox Business, just to name a few, you guys. She has space business experience, both in NASA with and startup companies as well. And so I cannot wait to hear her and all of her experiences. Camille, thank you so much for being here today, and I can't wait.
Yeah, I'm actually just getting set up. Sorry, I thought I had a few more minutes, so bear with me.
No
But it's so
worries.
great to be here. I'm excited to talk with everyone, and I hope the day has gone really well.
Oh, yes, it's gone amazing. While you get set up, I can pan over to a few of
I think we have a school with a hand up if we want to do that first. I don't know if you have
Yeah,
time for it
let's
or
do
not.
it.
Let's
Sure.
see. they have their hand up, but I don't know what school it is. It's just a student name. Can we unmute here? I see they're ready to launch, but I don't think they're at the computer to unmute. Well,
It's all right.
we
You want to
will.
launch?
I'm seeing her.
Oh,
Just
there they
getting this
go.
through.
No.
Sorry, we put you on the spot. Your hand was raised. You guys are ready.
They will be ready in a minute as soon as we get the string through.
Oh, we got a good question from Lassiter while we're waiting to get that up. And Lassiter, I think this is for Lonnie, if you're still on with us. How is AI changing how you do your jobs? And how does nuclear fusion shape the future of the projects that you do? So maybe you want to take the AI part of that?
Yeah, I'll definitely take the AI part of that because I've been pretty involved in it. This is my 4th class now at Notre Dame that I'm taking, which is AI based. I'm in, which is so interesting. It's just so exciting to see how this is going to change. For me, it's changed the way that I do my work and the way that I do my jobs and helped speed it up. I think kind of those background questions, the research part of projects that I do for school wise has helped me a ton for just creating a website. That's something that I did learn in class, but there are so many little debugging questions. And I'm sure with your projects, if you asked it something like, how do I do this? How do I do this? It has so many suggestions to try out. So for me, I think it's definitely changed my field as a student, but I hope for everyone it's changing for the better. And then I think it's also changing kind of even the way we drive and stuff like that. So
That is a super answer. There was one other question that had come up from Thomas County Central High School that you all asked, and I got a snapshot of you in there as well. You asked, how is the design systems of control and propulsion influenced by the environment of space? So this was such a great question. You'll notice on the screen, I kind of put a screenshot of how we kind of encapsulate our fuel and oxidizer propulsion and all that. We have to make sure that it's very pressurized in order to make sure that it's not going to leak out somewhere into the system or into the vehicle itself. But you'll also notice that if you look here, this is the shape of a thruster. We also feed the fuel and oxidizer down the lines, but it's not like Earth. You know, we don't have gravity in space to kind of pull the fuel and oxidizer in those lines. We have to push it. And we push it with pressurization, like nitrogen pushing through the lines to push it out into the rocket. And so we have valves up top that are kind of controlling that pressure. And then we also have valves that control if we let the oxygen or the fuel into the combustion chamber itself. So this was a super great question, Thomas County. Thank you so much for submitting that question. Camille, are you ready? I see you up and you're like staring at us, so I think you may be.
I am ready
ready to-
whenever. Yeah, but no rush on your end.
Please, let's go ahead and hand over to you. I know the students
Okay.
cannot wait to hear your story.
All right, I am going to share my screen. All right, can you guys see that okay? Yes, okay,
It
cool.
looks great.
Awesome.
Yeah.
Awesome, great. All right, hi everyone. My name is Camille Bergen, otherwise known online as the Galactic Gal. I'm an aerospace engineer by education. I went to the University of Tennessee, Knoxville, graduated in 2019, and then went to work on some really cool space technologies. I started working on the Orion crew capsule, which hopefully I can use my pointer, which you can see here. This is the structural test article. It's what we use to test how Orion is going to behave in space, but on the ground before it gets to space. And I did a couple of other engineering projects, but then I actually transitioned pretty quickly into business development and marketing within the space industry at both large aerospace companies and startups. So why did I do this? Well, I kind of quickly realized out of college that engineering in the real world was not really what I thought it was going to be. I think they do a much better job teaching now than even just 5 years ago, but you know, everything is so advanced today that we rely so much on computers to kind of do all of our engineering and, you know, support us and our jobs, which looks like, you know, a lot of coding, a lot of CAD, and that just was not for me. I know a lot of people that's what they want to do. And for me, it was just like, no, I love the technology, but I want to be at a more higher level, kind of leading strategy and business development, which in the space industry, we kind of like to say it's sales on steroids, because it's not traditional business, it's not traditional sales, because you also have to pitch to the government. So you're writing proposals, and you're also creating entirely new markets. So I spent several years creating markets in cislunar space, which is the space between one of the highest Earth orbits all the way out to the moon, and then actually on the moon, as well as markets like in space servicing. So I don't know how much you guys have talked about the current state of satellites, but basically nothing is serviceable. So you launch it, it's like you would drive a car, and if anything goes wrong or you run out of gas, like that's it, you have to buy a new car, except your cars are hundreds of millions, if not billions of dollars. So I did business development and marketing at both large aerospace companies like Lockheed Martin and startups. And now, as of this year, I'm doing Galactic Gal full time. What does that mean? Well, I help the space industry communicate our value to the public, investors, and potential future talent like yourselves, and also politicians. So I do that not only online through content, traditional short form content like TikToks or Instagram Reels or YouTube Shorts, but then also now that I'm full-time on this, I have a lot more time to do long form YouTube videos where I can do a lot more deep dives into the space industry, but still at a very accessible level to help people get into it. So I do that, but then I also do marketing for space companies still, kind of more on like a consulting level. And it's been really crazy this past year just to see like how much everything has changed, which is what I want to talk to you guys about today, is just the commercial space industry. So before I get into today's commercial space industry, I want to take you guys on a journey. So imagine it's the early 1800s. You're in a small, bustling town, and for the first time, you hear the hum of machines. Factories are springing up, replacing manual labor with mechanical looms and steam engines, and they're calling it the Industrial Revolution. And you can really sense the world changing before your eyes, even if you don't really understand what's happening. This was the dawn of modern manufacturing, and it radically transformed how people live and work as we now know. Now I want you to fast forward to 1903. And I want you to pretend like you're standing on the sands of Kitty Hawk, North Carolina. I'm actually from North Carolina, so a little bit of personal tidbits there. Of course, two brothers, Wilbur and Orville Wright. They've built a contraption unlike any horse, any train, anything that has existed thus far. They call it an airplane, and you watch it take flight for the first time. I mean, it's brief, it's just 12 seconds in the air, but you can sense how historic this moment actually is, because for the first time, we have conquered the skies, which forever changed the way we travel, as we now know. Now, another fast forward to the late 1990s. You're sitting before a bulky computer, listening to the screech of a dial-up modem. You guys might not even know what that sounds like, but it's really slow, and it does get connected to this new thing called the internet. You can send messages, you can find information, you can even shop all from home. And in just a few years, the internet will revolutionize communication, business, and global connections in ways that back then were completely unimaginable. But now today we're like, wow, we cannot live without the internet. And what is it going to look like going forward? So in each of these eras, people witnessed the world transform in real time, again, even if they had no idea the magnitude of the change. And today, we actually stand on the brink of one of the next major revolutions. We're living in one of those times that I just walked you through. And I'm not talking about AI or clean energy. Of course, here I'm talking about space. So today, in the next 40 or so minutes that I have with you, we're going to deep dive into this new space revolution and how it's set to radically transform the world as we know it, or worlds, I guess, plural, since we're going out to explore the moon and Mars and beyond. And we're also going to talk about a particular part of the industry that is really driving this growth beyond the technological innovations. That's the business development and marketing. So I'm going to give you a little bit of an inside look into what those roles actually look like and how you, as even an engineer or any sort of other technological background, or even no technology background, can be part of the space industry and do business development, marketing, high-level strategic thinking, customer interfacing, all these cool things. So let's dive in. And we're going to start by looking at the current state of the space industry. So in recent years, the space industry has undergone a completely remarkable transformation, shifting from government-led initiatives to a thriving commercial sector. Now, this change has ushered in a new era of space exploration and utilization with far-reaching implications for technological innovation, economic growth, and humanity's future, both on Earth and beyond. What does that look like? What has actually happened in the last couple of years? Well, in the last couple of years, slash actually the last couple of decades, satellites have become part of our critical infrastructure. So we talk about critical infrastructure here on Earth, our roads, our bridges, our power, our energy grids, all of these things, right? Communication, internet, et cetera. But we don't often think about how a lot of that is powered by what's in space and how what is in space is actually part of our critical infrastructure as well. Part of that is powering global communication, navigation, weather forecasting, disaster relief and management, financial systems, agriculture, and so much more. Basically, we could not live our modern lives without satellites, and that dependency is only increasing. So this graph actually shows the magnitude of that dependency. So in the last 5 years alone, look at this exponential increase. That is insane. And we've actually launched in the last 5 years, 3 times more satellites than in all previous decades combined. 3 times more satellites than all previous decades since the late 1950s combined. And this exponential growth is not expected to stop anytime soon. Eventually, we might see an S curve, but not in the near future. So today, the global space industry is valued at over $630 billion. And by 2035, that number is expected to triple, making space a nearly $2 trillion industry. And to put that into perspective, that's bigger than the entire global agriculture industry today. Like every piece of food that you eat that travels around the world, that your friends eat, whatever, the space industry is going to be bigger than that today. Now, obviously, the agriculture industry is going to grow, so it's not going to be bigger than the agriculture industry. It's just bigger than what it is today. So why now, and why exactly are we launching this many satellites? Like, what has happened in the last few decades to really make this technology advancement a reality? So to understand this, we need to go back in time again. And so journey with me back to the early 2000s. So in the early 2000s, there were less than 800 active satellites in orbit, 769 to be exact. NASA was actually just starting to build the International Space Station, and there were only a handful of rockets. We had the space shuttle, of course. The space industry was still largely dominated by a few government agencies and a handful of major aerospace companies around the world. And this was because launching satellites was an extremely expensive endeavor, often costing hundreds of millions of dollars per launch. Why was it that expensive? Well, back then, every rocket was used only once. And yeah, we still have some rockets that are used only once, but that's really not the case anymore, and definitely not going forward. And imagine building an entire airplane, using it once and throwing it away. That would be absurd, right? And the cost of air travel would be extremely expensive and actually prohibitively expensive for most people. That's really how launching things to space was. But then in the early 2010s, this company you might have heard of, SpaceX, they finally figured out how to make reusable rockets. And more importantly, they figured out how to do it at scale. So we talk about economies of scale. You can't, the way to bring things down, the way to make things cheaper is you have to be able to build it at scale. You have to have very large manufacturing and supply chain operations. So they figured out how to do that. And then very quickly after that, launching a spacecraft became 10 times cheaper, which fundamentally altered the economics of space. So you can see here, you get the 2010s when Falcon 1 first launched, and then SpaceX built Falcon 9. Falcon 9 has been flying for nearly 15 years, and it actually just last week hit its 400th launch, 400th successful launch. And as you can see here, the cost is dramatically decreasing. And Starship, when that comes online, if you're familiar with the new rocket that SpaceX is building, they really want it to be like $100 per kilogram and not tens of thousands of dollars per kilogram. And so suddenly space was accessible to not only large institutions and government organizations, but also private companies, universities, and startups. Space also became much more accessible to more and more countries around the world, not just major players like Russia and the US. I don't know why I said Russia first, but the US, Russia, et cetera. And now we have India, and we have China, we have Japan, and also all these other little countries that don't have like huge, massive bubbles on this graph, but do have smaller ones. And they are actually launching things to space to benefit their citizens in their countries. Other technological advancements over the last few decades, like miniaturized electronics and mass production, have also made it much cheaper to build and operate satellites. So we have launch, build, and operate have all gotten cheaper. So for example, you see here, satellites used to be the size of a school bus, and now they can fit into your hand. Not all of them. There are still some of the really big school bus size for different things, largely government operations, but a lot of things can be fit into your hand now. Additionally, all of the internal components used to be extremely expensive and highly specialized, because launching to space and putting things, as I heard a question when I first jumped on this call of like, how do you design something for the environment of space? Like, absolutely, not really the microgravity when it comes to like spacecraft components, but the radiation is really extreme in space. And so they had to build these really highly specialized components. And now many of these components are off the shelf and can just basically be purchased online. So the democratization of space technology has led to an explosion of innovation, with startups and universities now able to build and launch their own satellites for a fraction of the cost. And as a result, we're seeing an unprecedented surge in the number and variety of satellites orbiting Earth, each serving unique purposes, from environmental monitoring to rural connectivity. Okay, so that's kind of like where we are today, but what are all those satellites actually doing up there? We've launched so many satellites in the last few years. What are they doing up there, and why do we need that many? So I want to look at three major market segments, and the first is Earth observation. And I start with this one because I think that space often gets, one, a bad reputation, and two, the Earth observation side of things gets overlooked. But the Earth observation things is really why we launch things to space. We want to study Earth from above, and it's really the only way we can monitor a lot of things about our planet. And that's because they have a really unique vantage point. They capture real-time images and data of Earth nearly every minute of every day on a global scale. And that information helps us understand so much about our planet, from our weather and climate change to even estimated crop yields year over year. Now, can you guys do me a favor and pull out your phones if you have them on you? Don't go texting, just pull them out if you have them on you. If not, that's okay. Picture this in your head. So if you do have your phones out, I want you guys to open the weather app. That forecast that helped you decide what to wear today, it comes from satellites. And this is actually one of those satellites. It sits high above Earth and monitors atmospheric composition and weather patterns to not only bring you the day-to-day weather forecast that, tell you if you need a rain jacket or a parka, but also extreme weather events and prediction and tracking of those, like hurricanes. So all the aerial images you've probably seen recently, we just kind of concluded this year's hurricane season. Those come from satellites, and the data they provide is crucial for saving lives and property. And so, for example, I mentioned I'm from North Carolina. So if you guys remember Hurricane Helene's devastation across the southeastern United States, including my hometown of Boone, North Carolina, and where my grandparents live in Asheville, everything that we knew about and could predict from those hurricanes, and then also the associated disaster relief efforts that happened, was enabled or came directly from space and from satellites. Now, as you can imagine, with all this data about our Earth, oh, by the way, put your phones away, don't text. Actually, they will come back, so maybe just keep them on your desk. So with all this data about our Earth, satellites also play a huge role in our understanding of climate change. They allow us to monitor climate change on a global scale, as I mentioned, because they can see the whole Earth. They're spinning around and around and around all the time. And they also can see hard to reach areas like the poles. So we have satellites just going over and over the poles. And in fact, more than 50% of essential climate variables are measurable only from space. Why? Well, because from space, again, you can see the entire Earth and you can monitor changes on both micro and macro scales. So for example, satellites detect and quantify the concentrations of carbon dioxide and methane and other greenhouse gases in our atmosphere. These satellites can actually detect emissions from individual oil and gas leaks, which I find incredibly cool because we're looking from hundreds of kilometers or miles above Earth and they can see individual gas leaks here on Earth. NASA actually has a whole fleet of satellites called Landsat, dedicated solely to monitoring land use changes like deforestation or urbanization, which contribute significantly, as we know, to human-driven CO2 emissions globally. So these are real satellite images, and you can see from 2013 to 2018, the change in the land. There was a fire there in 2017 that the satellites picked up. That satellite data can then be fed into aerial observations, so drones or planes or whatever, or high altitude balloons. And then all of that data can be synchronized so that disaster relief efforts or policymakers or really anyone that needs to understand disaster management, deforestation, urbanization, et cetera, can really get all of that data. Here's another example. You can see from 2001 to 2016, this area, I totally forgot which area this is, my apologies, but the satellites mapped, look at that urbanization, look at that land change. And we can only see this from space. Now, if you're looking at these satellite images of land, now you might be thinking, okay, well, do they help with agriculture too? And the answer is yes, absolutely. Satellites play a huge role in agriculture. Farmers use satellite data to monitor crop health and optimize irrigation and predict yields. And this is so important to feeding our growing population in increasingly harmful environments. Today's farming equipment is actually incredibly high tech. If you didn't know, I didn't know this until a few years ago, but like basically John Deere is a technology company whose application is agriculture. The farming equipment being incredibly high tech is largely enabled by advancements in Earth observation and navigation satellite technologies. In fact, just last week, John Deere released their partnership with SpaceX's Starlink, which is a constellation of satellites in low Earth orbit that are providing global connectivity, which we'll talk about in a bit. But they just last week released this program so that farmers can get better data and better connectivity, even in remote areas where traditional communications here on Earth are very hard. All right, so that is Earth observation, and that's just tracking the surface. But as you can see, satellites are crucial to helping us understand and protect our planet and everything on it, including us. Okay, I promised you your phones would come back, so if you'd like to pull out your phones again, or just imagine what I'm going to have you do in your head. All right, I want you to open Google Maps or Apple Maps, Waze, whatever you use. And again, you could probably imagine this, right? But that little blue dot that you see that kind of like follows you around everywhere and like helps you get to the nearest gas station or coffee shop or whatever, that's there thanks to your phone picking up signals from at least 4 different GPS satellites at all times. This is one of those satellites. There's a constellation of about 36 of them sitting pretty high above Earth. And your phone gets signals from at least 4 of them at any given time. And you get XYZ coordinates and time. And that time is why you need that 4th one. But GPS does more than just, help you get to school or, whatever you use it for. It's revolutionizing entire industries and making everything so much more efficient. So for example, it's helping to create more sustainable shipping networks. So this is actually a satellite image of shipping networks around the world. Obviously, a little bit color graded and everything. But this reduces environmental footprints while ensuring, everything from food to medical supplies or any other essential good really can be distributed more effectively across the globe. And remember that high-tech tractor we just talked about? they're equipped with GPS now, which allows the tractor to autonomously plan the most efficient planting routes. And this boosts crop yields and cuts fuel consumption, all of which, as we know, is incredibly important in our, increasingly climate-driven world. We'll say that. All right, GPS though does more than that. It continues. So GPS is also the core infrastructure, keeping all of our devices and systems ticking in perfect sync. So it enables you to use a credit card or make an online purchase by ensuring the transaction happens at precisely the right moment. This prevents errors and fraud, obviously very important. And it also helps in high frequency stock trading. GPS timing is crucial where milliseconds can be worth millions of dollars. So again, just like Earth observation satellites, this is just scratching the surface of what GPS enables here on Earth. But let's move to our next market segment, the last one I want to talk about, which is actually the largest one, and that's communications. So everything from ships and airplanes to emergency response efforts have been using satellites for wireless connectivity for decades now. But next generation ones, like I just mentioned, SpaceX's Starlink, that have popped up in just the last few years are completely revolutionizing global connectivity. It's sort of like how we went from dial-up. Remember our example at the beginning. You might not remember that screech or know what it sounds like, but some of us do. And now we have gigabyte fiber. So we went from dial-up to fiber. And now more and more people can access high-speed internet around the world, especially in rural and remote areas. And it's also getting much cheaper to access this service. So this is a SpaceX Starlink terminal. It's very remote. You can take it anywhere. I'm actually even considering getting one when I go to national parks because I travel a lot to national parks and I also work a lot. So I need internet connectivity wherever I'm at. But these are helping us bridge the digital divide, expanding access to information and education and healthcare in traditionally underserved communities around the world. I'm going to bring the tractor back again because I want to reiterate that literally just last week, SpaceX's Starlink is now on a lot of the John Deere tractors so that farmers can get access to connectivity and help them plan their routes and their efficiency and even just, connect back to their farms if they're really far out in their fields, for example. So now even airplanes are starting to adopt Starlink Wi-Fi. In fact, United just announced a new partnership with Starlink a couple of months ago that's going to bring high-speed internet to their flights for free. And you'll be able to stream and play games on flights, which many of you know that you can't do that today. Okay, so that's a look into space for Earth applications, but what about human space exploration? So I want you to raise your hand if you were born after November 2nd, 2000. After 2000. Most likely, I think every single person on this call. Except the leaders, of course. All right, if you raised your hand, for your entire life, the entire human population has not all been on Earth at one time. And that's because there's been a human in space every single day since the first crew visited the International Space Station on November 2nd, 2000. Now, in that time, from 2000 to now, almost the end of 2024, researchers from over 100 countries have conducted more than 3,000 investigations in the unique microgravity environment of the International Space Station. And this has revolutionized fields like biology and medicine and physics. So, for example, what happens to an astronaut's body when they go to space? Well, we know that they lose bone mass, their muscles atrophy, their cognitive function can be impaired. They have issues with their eyesight, a whole bunch of other side effects. Extended stays in space actually accelerate physiological and molecular conditions, which enables faster and more comprehensive studies of human health. So what does that mean in more simple terms? That basically means if you have to wait an entire lifetime for someone here on Earth for their genes to change expressions, for for a gene to express itself in a different way, which means that your physiological and molecular condition has changed. If you put them in space, you can see that within a couple of days, actually. And so this research has led to breakthroughs in understanding and treating conditions like bone loss, muscle atrophy, and cognitive function disorders here on Earth. It's actually one of the main reasons we go to space, why we send humans to space, because it's very hard on the human body to go to space, but they're basically like human test subjects. Obviously, they sign up for it, but they're basically human test subjects to help all of humanity back on Earth. Now, the challenges of living and working in space are also driving innovation in areas such as life support systems, radiation protection, and remote medical capabilities that often have direct applications here on Earth. So, for example, how many of you have heard that astronauts drink their pee? Yeah, they do. And they can do that because the ISS has an amazing water filtration system. And it's actually incredibly important because resources are limited up there. Water is really heavy. And even though, as we talked about at the beginning, launch cost per kilogram of mass is decreasing, it's still really hard to get a lot of water into space because water is really heavy. And so they have this awesome filtration device on the ISS that takes the humidity from the air, the astronauts pee, wastewater, any sort of like water on the ISS, and filters it so that it can be reused into drinkable water. And also they use it to rehydrate their food. And that technology, it's actually this. So this is the giant one that's on the ISS, all the water filtration goodies. Well, they've repurposed this into technology that is bringing clean water to areas all over the world, which, as we know, is a huge issue right now. But the ISS is set to retire in 2030. So what comes after that? Well, instead of being replaced by another government-led station, right, NASA and Russia and JAXA, the Japanese Space Agency, all these government agencies right now own and operate the ISS. NASA doesn't want to do that anymore. Instead, it will likely be succeeded by commercial space stations, which are actively in development. And I actually did work on this one right here, this Vast Haven one, before I went Galactic Gal full-time earlier this year. These private orbital facilities are going to serve as a platform for research and manufacturing and even tourism in low Earth orbit, as we've started to see over the last few years. A couple still very rich people, and hopefully the cost will come down just like commercial airline travel in the coming decades. But they're going to space, and they're not just going for a joyride. They're doing real science up there that is having tremendous benefit for, like, particularly healthcare here on Earth. And so commercial space stations are going to usher in a new era of human exploration by driving more innovation, reducing costs, and being more accessible to not only NASA and other governments, but also civilian astronauts, like I just talked about, funded through private means, universities, research centers, and nonprofits. So why is NASA not making a new space station themselves? Well, by transferring routine operations in low Earth orbit to the private sector, NASA and other government partners can redirect their limited resources towards the next big leap, which is a permanent presence on the moon through the Artemis program, which, by the way, they're already partnering with private industry on to develop technologies like lunar landers. This is Blue Origin's lunar lander. This is SpaceX's lunar lander. Sorry, my computer froze. Okay, is it still frozen? No, okay, I think it was just on my end. Okay, sorry guys. But also, okay, so lunar landers, Blue Origin and SpaceX, lunar Wi-Fi, lunar GPS, and even mining technologies to help us live off the land there. Again, because everything is really expensive if we send it from Earth. And also not environmentally great for us if we use all of Earth's resources to send it to space. So before we get too far into the what's next, so that's the next big leap, let's recap the current state of the space industry. I know that was a lot. So as you can see, there's a lot going on, but here's what you need to remember. 3 things. 1, major technology breakthroughs in recent decades, such as reusable rockets, have made spaceflight much cheaper and more accessible. 2, as a result, we're launching more satellites to space than ever before. 3, each satellite launched serves a unique purpose, all of which are revolutionizing the way we live and work on Earth. And I know I said 3, but there is actually one more. Human space exploration is advancing not only our understanding of human health, but also spin-off technologies that benefit life on Earth. All right, so that's where we're at. Now, where are we headed in the next decade? How does a $630 billion industry triple over a decade into a $2 trillion industry, again, bigger than the current global agriculture industry today? Well, the foundation laid by current advancements in rocketry and satellite technologies will pave the way for even more innovation, technological breakthroughs, and commercialization of the space sector. And I want to go into some of the emerging markets. So over the next decade, we can see We can expect to see higher resolution imagery, more frequent data collection, and advanced analytics powered by big data and AI. This will enhance our ability to monitor and combat climate change, manage natural resources, and respond to disasters more effectively. The expansion of satellite constellations will provide global high-speed internet coverage, which, again, as I mentioned, bridges the digital divide and connects even the most remote areas of the world. And continued advancements in navigation technologies will enable new terrestrial technologies like fully autonomous vehicles. But this evolution will not only improve and expand existing markets, it will also enable the emergence of entirely new ones. So did you know that we are 3D printing organs in space? Why would we do that? Well, our gravity causes soft tissues to collapse under their own weight when 3D printed here on Earth. But in space, without gravity, we've proven that that problem doesn't exist. This technology is still in its early stages, but in the future, we could see entire space factories dedicated to 3D printing organs so that people don't have to wait on long transplant lists anymore. The lack of gravity also opens up unique opportunities for pharmaceutical development. So by removing gravity, you actually get better, more uniform protein crystals, which is fundamental to drug development. This enables the creation of higher quality drugs and groundbreaking therapies that are not possible to produce on Earth under our gravity, which could lead to more effective treatments for a wide range of diseases that impact millions of people worldwide. Another application that could improve everyone's modern lives is something called Z-blan manufacturing. That's Z-B-L-A-N. Z-blan is a special type of fiber optic cable that offers significantly higher data transmission capabilities compared to traditional fiber optics. But manufacturing Z-blan on Earth under gravity results in imperfections. So you can see all these little bubbles here. That degrades its performance. So if we can remove gravity, those imperfections are minimized. Look how clear that is. Look how clean that is. So this advancement could transform telecommunications, enabling even faster internet speeds and more reliable global connectivity. Now, in-space manufacturing isn't just about Earth-based benefits, it's also a game changer for building the infrastructure of the future in space. So currently, the size of what we can launch is limited by rocket capacity. But as demand grows for larger space stations and structures like space-based solar power arrays, or even those factories we talked about for 3D printing organs, we need to be able to manufacture and assemble massive components and structures directly in space. And I just mentioned space-based solar power, but what is that? Well, solar energy, as we know, is a great clean energy source, but we're limited by what we can collect here on the ground because the sun has to go through our atmosphere. If instead we used larger solar panels in orbit to collect solar energy and then beamed that back to Earth using microwave or lasers, we could provide an uninterrupted clean energy source that isn't affected by weather or nighttime. And this is an exciting emerging market that could play a really crucial role in addressing our global energy challenges. And another emerging market in the clean energy space is the mining of something called helium-3 from the moon. So helium-3 is a rare isotope on Earth, but it's believed to be abundant on the moon's surface. It has the potential to become a highly valuable resource for future energy production. Unlike traditional nuclear fuels, helium-3 could enable safer and cleaner fusion reactions with little to no radioactive waste. So if we can successfully locate, mine, and transport helium-3 back to Earth and figure out nuclear fusion, because we need to figure that out too, we could potentially power the entire world's energy needs for 10,000 years. 10,000 years just from the helium-3 on the moon. And speaking of mining, every piece of technology that runs our modern world, from your phone to the screen to everything else, but honestly, that runs on metals, are hard, expensive, and environmentally harmful to mine these metals. But demand for these metals is rapidly increasing. So what do we do? Well, one potential option is to mine asteroids. This might seem like sci-fi, and yes, it is still a few decades away, but there's a near limitless supply of resources in the asteroids in our solar system alone, and they don't have environments that we need to protect like Earth. So this would be a significant endeavor, but it could transform Earth's economy and enable space exploration because we could also mine them for water, which is crucial not just for drinking, but also rocket fuel. And another emerging market is actually something I mentioned that I worked on at the very beginning of this talk. It's actually called satellite servicing. So if you remember from the very beginning, I talked about how satellites aren't serviceable. What does that mean? Okay. Imagine buying a multi-million or even billion-dollar car. You can't take it to the shop. If something goes wrong, you throw it away, you buy a new one. Actually, you don't even throw it away. You just leave it on the side of the road. You can't fill it up with gas. And that's exactly what happens today. Satellites can't be refueled. So when they run out of propellant, that's it, they're done. And oftentimes they run out of propellant to maintain their orbit far before their hardware stops working. So we have all these dead satellites that could theoretically still be collecting data about Earth, but they're dead because they don't have any fuel to keep them up there. But maintaining, upgrading, and even refueling satellites in orbit is quickly becoming a reality. In-space satellite servicing will help extend the lifetimes of satellites already up there, reduce the need for entirely new satellites, and help us combat our growing space debris issue, which I'm not really going to touch on here, but I will just say one thing about space debris is that there's this thing called the Kessler syndrome, which is basically this theory that eventually we could have so much space junk in orbit that we're locked into Earth and we can't leave. Well, it's not just we can't leave, it's also with all that we've seen, satellites are critical infrastructure. So if they're all just crashing into each other and creating all this debris, all of our critical infrastructure would cease to exist. So the last emerging market I'd like to highlight is space tourism. We mentioned it briefly before, but it's no longer a distant dream. It's a rapidly developing part of the industry. So companies like Blue Origin are already offering suborbital flights for private citizens. Suborbital meaning you go up and you come back down. You don't actually orbit the Earth, but you do go to space and you do get some zero gravity environment. Other companies like SpaceX and Axiom Space offer private orbital flights, so orbiting the Earth, or even going to the International Space Station. And as launch costs continue to drop and commercial space stations come online, we can expect to see space tourism expand to longer stays in space for more people and more diverse people. And eventually, people might even vacation on the moon. Now, these are just a few of the exciting emerging markets in the space industry. There are so many more. And as the commercialization of space continues to accelerate, new markets could pop up that we aren't even thinking about yet. But one thing is for sure, private industry will continue to play an increasingly significant role. And this shift will not only drive innovation, but also create new job opportunities and economic growth. As we venture farther into space, the benefits will extend far beyond the space industry itself, impacting various sectors on Earth and potentially reshaping our entire global economy. So while challenges can be, sorry, my bad.
I was just saying, wow, that's amazing.
Yeah. So challenges do remain. This is not a walk in the park. This is not easy. Of course, we have issues like space debris management. We have international cooperation issues, but the potential for growth and discovery in the coming decade is insane, honestly. We, as I mentioned at the very beginning, bringing it back to, the 1800s and 1903 and the late 1990s, we stand on the brink of this new era of space industrialization, a new revolution in space exploration and utilization. And the next 10 years will be pivotal in shaping humanity's future, both in space and on Earth. Now, the last thing I wanted to talk about is how do we actually fuel this growth? Because it's not enough to just have a cool technology like asteroid mining. You also have to have a business case, funding, and support from both the public and politicians. And all of that is the job of business development and marketing professionals. So here I'm going to dive into a little bit more of these roles and kind of like what I did to maybe inspire you to consider these opportunities. Again, you can have a technology background, you don't have to have a technology background, but either way, I think that these are really awesome careers for people, especially that love to think big picture, think strategically, love the technology, but maybe don't want to be like myself, coding or doing CAD all day, things like that. Okay, so what is business development? Well, these roles are crucial in bridging the gap between innovative space technologies and their practical commercial applications. Business development professionals identify market opportunities, forge strategic partnerships, and secure funding to turn space ideas like asteroid mining into viable ventures. And marketing experts play a vital role in communicating the value of space technologies to potential customers, investors, and the general public, which helps to build support and enthusiasm for space exploration and its many benefits to life on Earth, which of course is so important. Diving deeper into biz dev, I call it biz dev because business development is a lot to say. Biz dev professionals in the space industry are basically architects who transform all of the cutting edge technologies into thriving ventures, as I just mentioned. So their role extends far beyond traditional sales, as I mentioned at the beginning. It's like sales on steroids. It's about identifying new opportunities, securing partnerships, and building strategic relationships that position their organizations for success in a rapidly and incredibly competitive and dynamic market. So take the example of reusable rockets. SpaceX's revolutionary technology didn't succeed on innovation alone. So to thrive, they had to prove the reliability of their system and secure launch contracts from NASA, commercial clients, and satellite startups. They had to demonstrate trustworthiness, cost effectiveness, and a compelling vision for the future of spaceflight. And by doing that, they reshaped the entire industry. It wasn't just about building better rockets, it was about building a solid business case that made reusable rockets an economic game changer and thus a requirement for the future of space. This strategic mindset is essential for all space companies, whether they're startups developing next generation satellites or major aerospace players vying for billion-dollar government contracts. Biz dev teams have to navigate complex regulatory landscapes. They have to anticipate market shifts, and they also have to clearly communicate their value to stakeholders ranging from government officials to investors. So to put a bow on biz dev before I dive deeper into marketing, even the most groundbreaking technology will struggle to lift off, pun intended, without the right business strategy in place. So imagine a company pioneering something like in-space pharmaceutical manufacturing. To bring that innovation to life, they need more than just new technology. They need partnerships with, say, commercial space stations. They need support from regulatory bodies like Congress or the United Nations. And they need customers willing to invest. It's like you can't develop a commercial product here on Earth. Like, let's say you have our iPhones, right? They couldn't just develop this really cool iPhone for nobody. They had to have a market. They were able to develop an iPhone. They were able to develop any of the technology that we have today that is like rapidly mainstream because there was a market. There was a demand for it. Okay. And lastly, the last topic is marketing. So historically, space companies haven't had a lot of marketing. They didn't really need to. Their only customer was the government until, like I said, the last 10 decades. But now with more commercial customers, investors, and a growing demand for more talent in the industry, marketing is becoming a crucial aspect of the industry. Because you can have the best technology or idea in the world, but if no one knows about it, it doesn't matter. Marketing in the space industry is all about storytelling and education. So actually, a lot of times I call myself a storyteller, which is pretty cool in the space industry. Unlike traditional technology or consumer products like a phone, space innovations are often really technical and abstract. You can't touch it, right? It's up above our atmosphere. Most of us will never get to go to space. Like it's hard to understand. So a big part of a marketing job in space is translating complex topics into language that resonates with people like customers and investors and even the general public, which is largely where I sit. Now, in recent times, the space industry has been subject to a lot of criticism. A lot of people argue that space is a waste of time and money, and that we should focus on our earthly problems instead. And that's valid, but that fails to fully recognize the critical role that space technology plays in our daily lives and addressing global challenges like climate change and food security and global connectivity, everything we've been talking about for the last 40 minutes. These opinions about, okay, billionaire space race, space isn't the answer for our climate, not Mars, blah, blah, blah. They're far reaching throughout the general public, which directly influences political decisions and the space industry's ability to secure the necessary funding and talent to continue innovating for humanity on and off Earth. So marketing professionals play a critical role in the space industry by addressing these misconceptions and communicating the tangible benefits of space exploration and technology to the public. Through strategic messaging, compelling storytelling, and educational initiatives, they are working to shift public perception and build support for space endeavors. This involves not only highlighting the direct application of space technology in our daily lives, everything we just talked about, but also articulating and educating about the long-term vision and potential of space exploration to solve global challenges and advance human knowledge. So all of this to say, business development and marketing professionals are key to the space industry's success in the coming decade. We need more people with strategic mindsets who can communicate complex topics effectively and compellingly. Space isn't just for rocket scientists anymore. The space economy is booming. We are quite literally on the brink of one of humanity's next major revolutions. We will likely see humanity become an interplanetary species in our lifetime, and there is space and a need for every type of profession and passion to advance humanity in previously unimaginable ways. So with that, that's it.
Camille, oh my goodness, you had so many amazing points. And I love how you're able to boil down those very complex topics into understandable ways for students. So our students have done a great job in preparing some questions for you.
Okay.
The first one we have for you, how did you decide at such a young age that you wanted to do something as complex as aeronautical engineering? And what inspired and motivated you to go into this field?
Yeah. So when I was 4, I saw a space shuttle launch. It was on the opposite side of the Florida Peninsula from the Cape. So you could only see like the trail, kind of like a plane flying above. But I was 4 and I looked up at my parents and I was like, I'm gonna be an astronaut. I was so enamored by humanity's ability to come together and build this big piece of technology that could launch humans into space and launch technology and everything into space. Now, obviously at the time I was probably just more enamored by like how cool it was. Over the years, as I got older and I started to learn more about like what we're doing in space and why we're doing it, particularly when I got into college, that's when I really was like, okay, this is like what I need to be doing, because I see space as a domain to do technology development and science. It's like the next frontier, right? And it's not it's just a new way for us, a new place for us to do technology. It did take me a while though. I grew up, so I saw the launch in Florida because we lived there for a brief time, but we moved back to where I'm from, Boone, North Carolina. So very rural, not a lot of access to STEM education. We didn't have Zoom. We didn't have social media back then. We didn't have virtual opportunities like this for me to learn about space. Or to learn really about any science career. I really didn't see any women in science or STEM in general. And I thought for the longest time that that was only for boys. And I really did. And my dad would always say I'd make a great engineer. And every time he'd say that, which was probably like 3 times a year, I'd be like, no, Dad, that's for boys, because I actually thought that. And that hurts me to say now. But it's like, thanks to the revolution of social media and just any digital media in general, now you can see anybody doing anything that you want to do who looks exactly like you, which I think is super cool. So it did take me a long time to get there. It wasn't really until college that I was like, oh, okay, maybe I could do this. But no, here we are.
So Camille, I was similar to you in that I grew up in a fairly remote area and I didn't have any role models to look up to or anyone to even ask questions about. We didn't even have the internet when I was trying to figure out how to go into the space program. So I feel like we are so blessed with you and being able to like reach so many students. Question for you though. Why do you think it's important for high school students to engage in astrodynamics?
I think it's really important because we have a STEM shortage right now, and it's only getting worse. So what does that mean? It means that we have a demand for a lot more STEM careers or STEM professionals than we currently have. So I think it's super important, as well, backing up, like when you're a kid, a lot of kids like love space, right? They all want to go to space. And then somewhere around like age 10 or something, like kind of late elementary school, early middle school, they stop caring about space and or really any STEM in general, right? And not everyone, obviously, but a lot of people. And that's really difficult because that's where we lose all of the STEM professionals that we need. And so I think it's really important for high schoolers to learn about what opportunities are out there for them before they get to college. You just get a bigger head start, and the world is changing so fast nowadays. Like having an engineering class in high school was like so over my head at the time, and now it's like ubiquitous everywhere, which is really cool. But we have all of these challenges that we need to solve, not just in space, right? But particularly in space, we have so many challenges we need to solve. We need space debris. We need to solve space debris. We need to, figure out how to manufacture satellites better so it's not as harmful to the environment. And then as we go and explore the moon, we need so many people to figure out, like, how do we actually do that? And how do we do it in a way that is beneficial to humanity, funneling those technologies back to Earth and making sure that we don't make the same mistakes that we have made here. Obviously, we're going to make mistakes. We're human, but we need people to get involved in this now because this generation is, one, the most impacted by climate change. Two, they are really driven by working in, environmentally friendly, sustainable industries, good industries that benefit humanity. And so getting involved early on in space in high school is just going to, inspire you a lot more to go out and be part of the industry and help us solve all of these challenges that we have.
Camille, we are so lucky that you brought this to our group. I caught a few takeaways that you had said. Number one, space is critical to our infrastructure here on Earth. And number two, we are on the brink of a new revolution, and you are helping inspire students all around the world, and especially the ones that are joining us today. So thank you so much for everything you do to bring this to everyone.
Yeah.
It's been an honor and a pleasure to be here with you today. So thank you for everything.
No,
And
thank you
Monica?
so much. No, it was a pleasure. And you guys are welcome to connect with me on any of the platforms. I linked my QR code there at the beginning, but if not, I'm sure that the team can help you guys find me online.